You'd think being born male or female is a permanent, settled fact for any animal. For this fish, it's more like a temporary job assignment. Depending on exactly who else is around it and what happens to them, this fish can fully switch from one sex to the other, partway through its life, on purpose, and it's not some rare glitch. For an entire group of fish species, it's actually the normal plan. Let's start with clownfish, because their system is one of the clearest examples. A clownfish group living in a single anemone has a strict, small hierarchy. There's exactly one breeding female who is the largest and most dominant fish in the group. Below her is a single breeding male, and below him a handful of smaller, non-breeding juveniles waiting their turn. Every clownfish is actually born capable of becoming either sex. They just develop as male first by default. If the dominant female dies, the group doesn't need to wait around for a new female to wander in from somewhere else. The breeding male, the second highest ranking fish in the group, begins transforming. Over the course of a few weeks, his body undergoes real physiological changes, developing the internal reproductive structures needed to produce eggs. He literally becomes the group's new female. At the same time, the largest of the waiting juveniles gets promoted, developing into the new breeding male to take his place. This particular pattern, male to female, is called protandry. But plenty of other fish species run the exact opposite system. In many wrasses and parrotfish, individuals start out as female and later switch to male, a pattern called protogeny. In these species, one large dominant male typically controls a whole harem of females. If that male dies or gets removed, the largest female in the group can begin transforming into a male within just days, taking over defense of the territory and mating rights almost immediately. So why would evolution favor this instead of just being born one sex and staying that way? The answer comes down to reproductive math. In both systems, being the dominant breeder of one particular sex produces dramatically more offspring than being a smaller, non-breeding member of the other sex. For a small subordinate clownfish, staying male and waiting indefinitely for a breeding opportunity might mean never reproducing at all. But if that same fish can become the breeding female the moment the position opens up, it dramatically increases its lifetime reproductive success. Evolution rewards flexibility here, because the fish that can seize a breeding opportunity the instant it appears will out-reproduce a fish that's stuck being the wrong sex for its social position. This flexibility is controlled by hormonal signals, not by any conscious decision the fish is making. Chemical cues, often related to social rank, dominance behavior, and stress levels within the group, trigger a cascade of hormonal changes that physically rebuild reproductive organs from the inside out. It's an entire biological system built around the assumption that sex isn't fixed, just optimized for whatever role gives an individual the best shot at passing on its genes. So the next time you watch a clownfish swimming happily inside its anemone, remember it's not locked into being one sex for its entire life the way most animals are. It's carrying the biological potential to become something else entirely, quietly waiting on a single event somewhere in its social hierarchy that could flip its entire reproductive identity within a matter of weeks.